Okay, this next stoichiometric calculation is going to go back to a titration calculation. So just make sure you remember to keep these steps somewhere handy nearby so you can follow them through as you go. Okay, so the one that we're going to be looking at this time is taking 25 mils of 0.0502 molar sodium carbonate, and we're titrating it against hydrochloric acid. We're getting an average titer of 23.6 milliliters, so it's asking us to find the concentration of the acid. So first thing I just want to point out, in case you aren't quite sure, is what this one here is, this big capital M. That's exactly the same as having moles per litre. Okay, big capital M for molarity. So that's our concentration. So first step, as always, is a balanced equation. So we've got sodium carbonate solution, Na2CO3, and we're reacting that with hydrochloric acid, HCl. Acid carbonate reaction gives us a salt, which in this case is salt, carbon dioxide, and water. Okay, just type over right at the top of that. To balance this up, we need a 2 in front of our sodium chloride, and we need a 2 in front of our hydrochloric acid there. Okay, balanced equation, really important. Next step is to write down what you know. Okay, so if we have a look up here in our equation, we've got 25 mils of 0.0502 sodium carbonate. So we add that in to our equation here. We have a volume of 0.0250. Practice converting from milliliters into liters so you can do it really quickly. And we have a concentration up here of 0.0502. Okay. What we've got also from the equation here is an average titer of 23.6 milliliters. Okay. So that's our volume of hydrochloric acid, 0.0236, and it's trying to find us the concentration. All right, that's what the question's asking, concentration of the acid. So sometimes if you want, it actually helps you to highlight that as well, and that just helps you to know what to write down. Okay, so next step is to calculate the number of moles of our known. The known is the one we've got 2 values for here, which is this one, the sodium carbonate. So our number of moles of sodium carbonate is C times V, which is 0.0502, okay, times by 0.0250. So again, if we're doing this in the exam, we'd go through and we'd calculate this answer, and in this one we'd probably give it to 3 significant figures. Okay, we're not going to calculate it now because we're just going to keep going to concentration of the acid. Next step is to calculate our mole ratio. So we've got our unknown on top, so number of moles of hydrochloric acid, and number of moles of sodium carbonate on the bottom. So what we do is we have a look up here at the equation, and the hydrochloric acid has a 2 in front of it. Okay, so it's equal to 2 over, and up here in front of the sodium carbonate, it's not written, but there's a 1. Okay, so it's 2 over 1 is our mole ratio. And we're going to use these ones together to get our number of moles of our unknown. So if we go to the next slide, we're trying to calculate the number of moles of our unknown, which is hydrochloric acid. So it's number of moles of our sodium carbonate, which was, if we went back to our equation, right, for our values there, it was 0.0502 times by 0.025, that was our number of moles, and we're multiplying out by the mole ratio, which was 2 over 1. Okay, so that's going to give us our number of moles of hydrochloric acid. So then we need to calculate what the question's asking us, which is concentration of hydrochloric acid, C equals N over V. So we're going to take this value up here, all right, which is our number of moles. So it's going to be 0.0502 times 0.025 times 2 over 1. That's our number of moles. We're going to divide it by the volume of hydrochloric acid, which was our average titer value. All right, and that was 23.6 mils, so 0.0236. Put that all into your calculator, providing you haven't been rounding off in the previous steps. If you've been working out the answer as well, you'll get a 0.106 moles per litre. Now that is to 3 significant figures, because if we go back and have a look at the question, up here, 3 significant figures for our volume, 3 significant figures for our concentration, 3 significant figures for our volume here as well. So all in all, that gives us 3 significant figures. That's why we give our answer to that as well, of 0.106 moles per litre. Hopefully by now you're getting the hang of it. All right, but again, go back, try it, make sure you can do it. Make sure you can do it step by step. All right, because once you've got the basics of this, once you start introducing things like redox equations and back titrations and stuff like that as well. If you've got the basics, it'll be really easy for you. Okay, thanks guys.